What's up everyone, welcome back. Patrick here, moving on to the next video. So we have to find the domain of these two functions here. So notice they're actually the same function, they're both rational function. The only difference is that this denominator is 2 minus 3x, while this denominator is the square root of 2 minus 3x. And those two differences is actually going to make a difference in the domain. Now starting with this one over here, we have a rational function. So notice that the denominator can never be 0. You can't divide by 0, that would make it undefined. So basically 2 minus 3x can never equal 0, which means 2 can never equal 3x. And if we divide both sides by 3 to isolate for that x, it means x can never equal 2 over 3. And so for this function, the domain is basically x can be any real number except for 2 over 3. It can't equal 2 over 3. So one way to show it in set notation is x is an element of real numbers such that x cannot equal 2 over 3. That's the one condition. You could show it in interval notation as well. You could say x would be an element from negative infinity to 2 over 3, but not inclusive of 2 over 3, so we put a circle bracket there, or from 2 over 3 to positive infinity. Right? So any real number besides 2 over 3, that's what the domain would be for this first function. Now, this second function, the domain is going to be a little bit more strict. Notice that x can't be 2 over 3 again, because 2 over 3 would make this 0, and then the square root of 0 would be 0, and then the whole denominator would be 0. However, because there's a square root, remember a square root can't have a negative number within it. Right? So not only can 2 minus 3x not equal 0, it has to actually be greater than 0. It has to be a positive number. So it can't be 0, it also can't be any negative number. So 2 minus 3x has to be greater than 0. And so if we isolate for the x this time, it means 2 has to be greater than 3x. Divide both sides by 3. It means x has to be less than 2 over 3. Now, if you just want to make a note when you're dealing with inequalities, you got to be careful. When you bring the, if you did it the other way and you brought the 2 over, you'd have negative 3x is greater than negative 2. And then if you divide by negative 3 here, notice the negatives would cancel out, but because you're dividing by a negative, you have to flip the sign. Right? Whenever you're dividing by a negative, an inequality, you have to flip the sign. That's why I usually like to isolate for the x in a way where when I bring it over and I divide by a positive number, so I don't have to worry about flipping it. Right? So whether you do it this way or this way, x has to be less than 2 over 3. So that would be the domain for this function right here. So it would be x can be any real number such that x is less than 2 over 3, because any value that's going to be greater than 2 over 3, if you plug it in here, it's going to make this square root negative, and you can't square root a negative number. And if you put it in interval notation, you would say x is an element. Since x has to be less than 2 over 3, it would be from negative infinity to positive 2 over 3, and not inclusive of 2 over 3 because that denominator can't be 0. Right? So just putting a square root there really does change up the domain of the function.